Hello, everybody. We're going to start a little bit early today. My name is Rachel Cohen. For those of you who don't know me, I'm the Vice President of ITS Georgia, and I work with 360 Network Solutions. Tom is at ITS America today, so you get me. Couple of housekeeping updates. Membership is still live to be a part of ITS Georgia. The monthly meeting fees have increased if you are not a member, so I would encourage you all to go to whoever writes the checks and ask them to sign up to be an ITS Georgia member as soon as possible. With that being said, the annual meeting room block is also open for Jekyll Island for September 24th to the 26th. So go ahead and reserve your rooms. We will have registration and exhibitors opening in the summer, May, June, and we do still have sponsorships open. We have 2 diamond sponsors, still need to fill a diamond sponsorship, and then so forth. So Holly Painter is leading that, or you can reach out to Emily or anyone on the board for questions about that. Elections, we are looking for nominees, either self-elected or nominate somebody that you think would be a good board member. We have all 4 officer positions open and several board member positions open. So if you're interested, if you have any questions, any of us on the board, Emily, Winter, Farah, you can talk to any of us and kind of find out what kind of volunteer roles there would be and if you could be of value to ITS Georgia. That's really all I have. The one big thing I'm sure you guys all saw, they're having a big event here at 1 o'clock today. So we are trying to end this meeting around 12:50, and we just ask that you leave immediately. They are shutting the roads down. So unless you want to stay and watch the International Bikers, I believe it is, they need everybody off the property by 1. So say your goodbyes and goodbye. Our sponsor today is Q-Free, and I believe we have Lucas here. Oh, yep, if you want to come up, say a couple things about Q-Free, and we really appreciate your sponsorship. Hi.
Thank you.
You're welcome.
Hey, everybody. My name's Lucas Fajeda. I see a couple familiar faces here. I'd like to thank you guys for letting Q-Free sponsor. Q-Free has been working, well, formerly Intellite, working with GDOT for quite a long time, way before I even graduated school, so it's pretty cool to see. But I'd just like to thank you guys for letting me come. It's my first time here, so I'm trying to enjoy it as much as I can, and y'all have a great day. Anything else?
No, that's great.
Okay, cool. Thank you.
Welcome, thank you. One last announcement so Emily Dwyer doesn't get mad at me. We do still have 1 sponsorship open for December. So if you've not registered to sponsor a monthly meeting and you'd be interested and want to come up and share a little bit about your company, Emily would really appreciate you. So you can find her and talk to her if you're interested. Oh, Emily with GDOT. So if that makes you want to do it even more. She's with GDOT. Also with GDOT is Caitlin Stewart, who's going to come up and introduce our speaker for the day. You just need to stand close to that thingy, but you can hold it if you want.
Okay. Oh, I'm very short. Okay. Hi, I'm Caitlin with GDOT. I work in the SIGOPS group, but I did have the pleasure of working in ITS for a little bit and working with Ben. So thanks for coming today, and we're really excited about this presentation. So Ben graduated in 2016 with a bachelor's degree in civil engineering from Georgia Tech. After 3 years in building construction management, Ben began working with GDOT's Office of Traffic Operations in 2019. He started his career with GDOT in their Signal Timing and Operations program. In this position, he was responsible for the management of signal operations contracts for over 300 of the most heavily trafficked intersections in Metro Atlanta, maintaining the Flashing Yellow Era Upgrade Program, and working closely with GDOT agency partners to maintain and upgrade signalized intersections. In 2021, Ben was promoted to the Assistant State ITS Engineer of GDOT's statewide ITS program. In this role, Ben oversees the operations, design, and maintenance of the state's ITS infrastructure and project management for the state's ITS construction and rehabilitation projects. So let's welcome Ben.
Good afternoon. Can you guys hear me fine? Thanks. So I'm Ben Lempke. I'm the Assistant State ITS Engineer with Georgia, and today I'll be presenting on GDOT's Commercial Motor Vehicle Safety Alerting System, also known as Drivewyze. So Drivewyze is a software platform predominantly focused towards commercial motor vehicle users. So what makes it different is it runs on the electronic logging device that's in most commercial motor vehicles today. So if you're not familiar with the electronic logging device, or the ELD, it is a hardware that is regulated, or I guess there's a regulation that most commercial motor vehicles are required to have them in the vehicle, and they track driving time to make sure that drivers don't drive over the federal regulated hours per week. In addition to driving time, it collects a lot of data from the diagnostics port of the vehicle. So it'll collect GPS data, speed data, erratic driving behaviors such as hard braking. It collects a lot of different kinds of data like that. So that makes it that makes Drivewyze unique, the fact that it can run on this hardware. And just to kind of give you a visualization of what that looks like, it kind of looks like an iPad on the dash of a commercial motor vehicle. So there's a lot of different manufacturers for these ELD devices, and Drivewyze works with over 120 of those to come pre-installed on the device. So Drivewyze has a couple different applications, and just to note, these applications are always running on the ELD, so they don't necessarily have to be open like a lot of your applications on your phones. So the two primary applications are Drivewyze Pre-Clear, which that is a paid service that Drivewyze offers to fleets. It's a waste station bypass service. And the one that I want to talk about today is Drivewyze Safety. So that's a free application. It's proactive safety alerts tailored towards commercial motor vehicles. And I guess just to note, you can also download the Drivewyze software on your cell phone, so it's available on the Apple Store and Android Store. So where does Drivewyze fit into an agency? Well, it's just another traveler information messaging tool for us. So as traveler information messaging evolves, some things like highway advisory radio, the user base for that isn't as large as it once was. Some states don't have highway advisory radio anymore. 511 phone systems are still in use. They're still valuable in their own ways, as are roadside signs. We have them strategically deployed across our state, and we continue to deploy them today. They're very valuable to be able to target specific messaging to every driver on a certain route. The 511 website, it's capable of ingesting even more and more data, such as weather data, work zone data, speed data, as are your navigation apps are able to collect more and more data, provide travelers more and more information. But as we kind of look towards connected vehicles and even fully autonomous systems, what traveler information starts to look like, the evolution of it, is something that's kind of in your cab, in your vehicle, your own specific DMS device that can broadcast messaging that's unique to you. And tailored towards a specific driver. So that's what Drivewyze is for its users. It's an in-cab messaging. It displays in the form of a road sign for messages intended specifically for that driver and tailored towards commercial motor vehicles. So we kicked off our partnership with Drivewyze with a pilot project in 2020. There's kind of three main components to the pilot project, so I'll walk you through that. The first was to, I guess I should say, this was a pilot project for their Smart Roadways tool, which is part of the Drivewyze safety application. And what that is it's location-based safety messaging that is issued by the agencies. So the first step of this was to identify those areas that we wanted this location-based safety messaging. So we wanted to find areas that were of elevated risks to commercial motor vehicles. The second piece of that is the messaging. What kind of message did we want to send? What did we want? What are we trying to prevent with that message, as well as set the parameters around that. And the third, we wanted to be able to collect data through this pilot project and be able to analyze what kind of impact these alerts are having on driver behavior. So I'll start with the first piece of that, which was determining the location. So we brought in as much data as we had available to us. Crash data was a predominant piece of this. Using GDOT's new metrics platform, we can easily focus crash data by severity, crash type, the involvement of commercial motor vehicles. This is a heat map here shown pulled from new metrics that kind of gives you a visualization of how we can kind of key in on those hot spots where we might want to focus on further. We also considered other factors such as roadway geometry, volumes, vehicle classifications. And for the pilot project, we decided on these 5 locations. So we tailored messaging for 10 total sites across these 5 locations. Many of these are interchanges, so they include multiple different approaches. So we included the Cobb Cloverleaf interchange, 285 at 75, the I-285, I-20 West interchange, I-20 at Thornton Road, I-75 at Jonesboro Road, and I-75 at 675. And these were the locations chosen for the pilot project. Next, we needed to decide what kind of message we wanted to send to each of those locations. So each location, we wanted to look at what the crash data is showing us. What kind of crashes are we having? What are we trying to prevent? And then we wanted to make sure that the messaging was succinct, that it's not distracting to the driver. I should mention right here is a photo of what those messages look like on the ELDs. So what they do is they pop up with an audible beep. The driver can either disable them with a tap, or they can wait for 10 seconds and it'll automatically disable. So with that, we also wanted to set the parameters around where the messaging would occur. So we wanted to make sure that we're giving the driver enough time to react, but not too much for the message to be irrelevant or seem irrelevant. So I'll run through a couple examples of how we did that for these locations. So at Cobb Cloverleaf, we looked at all 4 approaches to that interchange, and the crash data were showing a lot of side swipes, a lot of rear ends, same direction type crashes. And we're also able to pull in the hard braking events from the ELD. So Drivewyze is able to collect that data to further help our analysis, and coupling that data with traffic patterns. What we noticed here was it just seemed the general congestion of this interchange. It's routinely congested throughout the day. And so this is the messaging that we decided to display to these approaches. Again, going back and figuring out where that message needs to be placed in order to allow the driver around 20 seconds at highway speeds to react. This is another example, 75 at 675. Again, we were seeing a lot of run off the road accidents. You can see the density plot of the hard braking right at the curve there. So this is the message that was chosen. Same methodology as far as placing the message where it will show up about allowing the driver about 20 seconds to react or to slow down. So now I want to get into the results of that pilot project. So I do want to mention what we used as a study topic for this pilot project was hard braking events. So we didn't look at speed data. Speed data can get really noisy. It's really high variability. It's got a lot of dependencies. It's hard to draw a lot of concrete conclusions from it. In addition, there's been studies that have shown that hard braking is a better indicator of crash potential than speed differential. So that's why hard braking specifically was chosen for this pilot study. Again, we're trying to prevent crashes. So we saw positive improvements at most of these sites, ranging between 4 to 19%. There were a couple that were statistically, insignificant just due to a low data set. And so that was the 50% at the northbound approach of 75 285 and the negative 3% at the southbound approach at 285 and I-20. The I-20 westbound at Thornton Road, that one stands out. That one is a pretty significant negative response we saw there. We actually never did a follow-up study to, strictly determine what was the cause of that, but there's a lot of different things that could go into it. One of them, this is an exit-only interchange, so if the polygon for the data collection isn't placed properly, you may be collecting more data from that exit-only lane, which tends to have a lot more hard braking events just due to people not realizing it's exit only and merging back into traffic. But there's a couple other things we looked at, but never really fully understood what was the cause of that anomaly. So it sticks with the results there. But like I mentioned, we did see positive results through this pilot. And through that project, we did have the option to renew the services, which we've done, and we've expanded to a few additional locations since then. So a couple locations at the 1675 interchange near Macon, at the 1695 interchange near Savannah, and one at the connector at I-20. This is a lot of data, so don't worry about trying to read into it. This is just a snapshot of the dashboard that Drivewyze provides its agency partners for these smart roadway locations. So what we can do with this is we can see how many alerts we're getting out to drivers, how that trends month to month. Again, this is a Tableau dashboard, so we could filter it down by specific time ranges or specific locations. We can see the speed variability between those drivers who are receiving the alerts and those who are not. Again, speed is a noisy data set that's difficult to draw concrete conclusions from, but with enough underlying data, we're able to kind of get an indication of if the alert's having a positive effect on driver behavior. It also allows us to spot some areas where we might want to go back and tinker with either the message we're sending or where we're sending the message. And so we can do that using this platform. The next thing I want to get into is our latest effort with Drivewyze, and this started about a year ago, and this is real-time safety alerting using INRIX probe data. So GDOT purchased INRIX probe data, or INRIX commercial vehicle safety alerts. So they have two types of those: sudden slowdowns and congestion. So when INRIX creates one of these events based on the probe data, then Drivewyze gets that information and they're able to distribute an alert either 2 or 3 miles ahead of that event. And then Drivewyze will collect the data around those notifications and share it with their agency partners, so we can see where the alerts are occurring, how frequently they're occurring, how long they're lasting, stuff like that. So just to dive into those two types of alerts a little more and how INRIX defines them. So again, INRIX is using vehicle probe data. So whenever they see that the current travel time, they make a comparison with a historical period from the same time last season. So what we're looking for with this traffic congestion is abnormal traffic congestion. So that's why it compares to the same season last year. If that travel time is 3 minutes or more, it'll define that as a congestion event, and that's the message that we send out 3 miles ahead to the drivers. The next one is a sudden slowdown. So if there's two adjacent probe data speed segments, if the upstream speed segment drops by more than 35 miles per hour, then that's defined as a sudden slowdown. So if you're traveling at 70 miles per hour and the speed segment upstream is 35 miles per hour, that would be a sudden slowdown. So the driver gets that notification 2 miles ahead. This is just a heat map showing where those alerts are occurring. So we purchased 500 vehicle roadway miles for these alerts. So that covers all of I-95, all of I-16, and these alerts. So that covers all of I-95, all of I-16, and from 75 from the Florida state line up to like the Locust Grove area. And again, this is another one of those Tableau dashboards that Drivewyze creates for us to be able to visualize the data around these alerts. So we're able to see how many alerts we're receiving, on what days, what hour of day we're getting those alerts, how long they're lasting. And again, we can filter it down as needed. But typically we're seeing that we send about 10,000 alerts per month. March was a pretty busy month, so that one was about 12,000. And finally, I want to get into some of the upcoming activities that we've been talking to Drivewyze about and are working to get involved in. The first one is work zone messaging. So they've worked with NCDOT doing this work zone messaging and found that 70% of alerted drivers slow down ahead of the work zone. So that's definitely something we'd like to try out as an agency. And there's a couple different ways to do it, but it ultimately comes down to getting a reliable work zone data stream to Drivewyze to be able to broadcast these messages. And I like to put the emphasis on reliable stream. We don't want to have outdated data that might saturate these alerts with bad information. We want to make sure that especially these alerts coming from the agency are very reliable. So again, we can do that data stream like through our ATMS platform. There's also vendors such as LiveLink who work with agencies on their work zone management to get a really detailed, reliable work zone information real time with real-time statuses. So that's something that we're looking into, the best method for that. The next is establishing like a virtual sign network for the state at predetermined locations. So what this looks like is basically just using Drivewyze as like a virtual DMS. So again, we're not going to reach everyone that a DMS would, but we are reaching those Drivewyze customers, and these messages would be real time, could be sent out by the TMC operators at specific locations for high profile incidents such as severe weather, or an all lane closed event, or an impactful work zone, something like that. Next, so Drivewyze being a infrastructureless software license, it's relatively inexpensive to the department from a traveler information, side of things. So if you look at like a DMS sign, something that requires infrastructure, is much more expensive. So this is something that we do realize benefit in just by the number of alerts we're getting out. So we're getting out thousands of alerts per month for these specific safety events. Based on our pilot study, we know that it's having a positive impact on driver behavior. But we would like to kind of see the data behind what that benefit cost looks like. And so Drivewyze has come up with a return on investment calculator, and they've based that on the FHWA TOPS BC benefit cost tool, and as well as some other university studies. And they've shared that with us and their other agency partners to get some feedback on, try and fine tune it. And ultimately, they want to share it with like university partners to get some third-party verification. And then this one we're really excited about. As I mentioned, the speed data is not a great indicator. It's hard to draw a lot of conclusions from it. So Drivewyze is going to start getting this telematic data to us, this data showing these hard braking events, how severe they are, where they're occurring. And this will be a great tool that we can use as really a standalone safety tool to identify hotspots for further analysis, maybe specific safety projects, and then also something that we can use to further analyze the impact that these alerts are having on drivers, and try and fine-tune that the best we can. So now I just want to finish up by reiterating some of the advantages that we see using Drivewyze. So drivers are alerted even if they're not using the navigation app. So again, this software runs always on the device, so even if they don't have the application open or anything, it's going to pop up with those safety events. Unlike maybe some navigation apps, you might have to have the device open or the application open. Second, it's an audible visual in-cab alert, so it's a visual road sign. It's got audible beep, so it draws the driver's attention more than maybe a static road sign or even a smartphone maybe. And third, physical road signs, they can be outdated, they can be not placed appropriately, they might be placed too closely to a risk area. That's a huge benefit of Drivewyze, is we can tailor where that message goes, we can tailor what the message says, and it's all, practically free. Fourth is that trucks help slow down the traffic around them. So again, these messages are geared towards commercial motor vehicles. That's the biggest user population. Again, the biggest benefit of it is on the ELD. So as these trucks are alerted and they drive more safely or they slow down ahead of a risk event, it also helps slow down the traffic around them. And fifth, drivers and fleets love the alerts, especially for drivers driving in new areas that are unfamiliar with the road. They find a lot of benefit in these safety alerts. Again, the Drivewyze safety alerts are free to any users. And then Drivewyze has been also a great partner to the department. They've been a really responsive partner who's tried to help move the program along and find areas of improvement. So we've been really happy with our partnership, and now I'm ready to take questions. So I'll hand the mic around for questions. Never mind, got one.
So I saw you guys did the hard braking analysis. Have you guys actually looked at crash data analysis to see whether this? I don't know if this is even on this. To see if it is reducing the amount of crashes for commercial vehicles.
So you're asking if we looked at crash data analysis. I'm just going to repeat everyone's question so we can make sure that everyone hears it. you're asking if we've looked at crash data analysis to see if it's having an impact on actual crashes. No, we haven't. Again, so crashes in themselves, that's another thing it's just got so many variables, it's hard to draw conclusions from it. That's why we find something like hard braking is a good indicator for the potential for a crash. So no, we haven't.
Kind of just following up on, but not exactly that, but is hard braking predominantly an indicator just for rear end crashes? Or what about the other potential type of crashes, and is there a metric that can potentially reduce that as well?
Okay, so you're asking if hard braking is predominantly just a measure of rear end crashes. Not necessarily. So I think I showed the density plot earlier for where we decided to use the sharp curve warning. That one we were seeing a lot of run off the road accidents, and the hard braking was right there at the curve. So I don't know that it's necessarily a run off the road accident, but typically a hard braking event is a good indicator that there's a high potential for some sort of accident to occur. So that's, again, why it's kind of a good indicator that we like to use for this. And what was the second part of your question?
Oh, just that.
Okay, great. All right.
How much Drivewyze vehicles account for among all the commercial vehicles in Georgia?
Are you asking how many drivers use it?
Do you guys have a count, like approximate percentage of Drivewyze?
Trucks, among all the trucks.
Yeah, I feel like I know the percentage, but I can't recall exactly. So it is in, I think, 2.7 million commercial motor vehicle users today, whatever that may come out to be, like within the U.S. I keep looking at Emily in case she has me.
Do you have any have you guys heard back from any of the drivers, like anecdotal information about what kind of alerts are most helpful to them, or what alerts that they might want in the future?
You're asking if we've heard back from any drivers on the alerts that are helpful for them and any that they may want to use in the future. So yes, Drivewyze does do customer surveys, and but no, we haven't gotten into I guess the impact of the specific alerts that they may want to use. But that is something that we've talked to them about, is trying to set up a survey specifically for our purposes that's useful for us. So that's a good suggestion.
You don't have to bring it over here.
We're recording.
Oh, well then there you go. All right.
We just started using some of the RITIS data for some travel demand modeling and so forth. I was wondering, looking at your map of the intersection or the interchanges and all that, I didn't see Spaghetti Junction, but I was wondering if maybe you had folks who had been on, like, say someone's on 75 and they come through and they're going through the whole network, and then they can see, the changing of the alerts as they go through other interchanges, and didn't know if that was something that's probably anecdotal, but I just thought of if the RITIS data would be helpful to combine with this at all. And not really sure what I'm asking, but I'm just wondering if that's
okay. Yeah, I mean, so kind of going back to the real-time alerting that we're using the INRIX data for, I think that's kind of on the same level. So again, RITIS is predominantly using probe data, as well as INRIX draws, or we purchased that probe data through INRIX. So yeah, again, I might have missed your question, but we are not doing those NRICS alerts in the metro area. Again, it's just covering 500 roadway miles. And the reason we chose those corridors is because of the way that we paid for them. So it was through a freight and rural development lump sum project. So I think that was the reasoning behind choosing those corridors. But ultimately, we do want to expand that. We have found benefit in it, and we would like to get this telematic data analysis to kind of see the impact that those alerts are having, because right now we're really just capturing how many alerts we're getting out, which is great in itself, that we're being able to identify drivers ahead of these sudden slowdowns or congestion events.
It might be neat to also apply onto freight rail networks as well, but that's another whole discussion.
So I have a question. So in your presentation, you show for the pilot study, you have 10 different sites, and you mentioned you want to expand on that. I'm wondering, what's the biggest challenge to expand these locations? Because you mentioned they are hand-picked, manually identified locations. Are identification of these warning zones intensive in terms of engineering, or are there ways to scale it that are more sustainably?
Let's see, you're asking about the expansion of the pilot project with that. That's what they call smart roadways, this location-based messaging, and how intensive it is to expand that. It all comes down to a data collection effort. So really, it's not that difficult to collect the data that we need. But I mean, the overall process of the data collection, and then the messaging, setting up the actual parameters around the messaging, not an entirely intensive process. Yeah, I guess we would be open to expanding it, and we have expanded it. It's just, yeah, where we're gonna, I guess, yeah, figuring out where to do that. Again, we're trying to tailor towards commercial motor vehicles and where we can make the biggest impact for them. So hopefully that answered your question.
Do we have any idea in terms of those commercial vehicles at long distance or just regional versus national? It's just a sample.
You're asking if we have any idea or any indication whether these commercial motor vehicles are regional or, I guess, more long haul. No, that may be some data that Drivewyze collects on their fleet partners, that they might have some indication of, but what we do collect is the alerts that we issue. We're able to see if those are unique visits or if they're return visits. So typically, I would say it's probably about 60% of the vehicles are not unique. So maybe you can draw some sort of conclusion there that maybe about 60% of the vehicles are more regional.
Great. Thanks, Ben.
Thanks.
Thanks, Ben. Thanks, Caitlin. And now it's time to throw all your trash away and get out before they close the roads. Have a good day, everybody.